Hi, this is Miss Litton, and this is 7th period support. Say hi. Hi. For Honors Biology, the immune system. So, first thing we need to remember is how extensive the immune system is. Oh, sweetheart, can I have you move into, everybody's taking pieces over there. Sorry, you just didn't know that. Extensive the immune system is, and then you just want to remember the functions, okay? So, as far as the functions go, we talked about this, absorbing that excess tissue fluid. So that was like number one function, right? And we know that the cardiovascular system and the lymphatic system are totally connected. And so out at the capillaries, where you have hydrostatic pressure forcing fluid out and osmotic pressure drawing fluid back into our capillaries, then any leftover fluid gets picked up by the lymphatic system from around those tissues, and it gets put into...
Oh, I'm so sorry.
That we get put, once that fluid is put into your lymphatic vessels, what do you call it then?
Best song ever.
What do you call it then? When it moves out of your tissues? Lymph. Exactly. So it absorbs excess tissue fluid and then it's called lymph. Okay, another job is it produces lymphocytes. Okay, and specifically, we are talking about the B and T lymphocytes, and then the natural killer cells. Remember, they're also produced, and that is a lymphocyte. It just doesn't go to the thymus gland to mature. And then the third item is it absorbs fat at the small intestines. Okay, so those are your three jobs. We looked at some terms like edema, when it is unable to pick up that excess tissue fluid. That can cause problems. We talked about how the fluid will move in your lymphatic system similar to how it moves, thank you, in your circulatory system. Well, you're welcome. What keeps the fluid going the same direction?
The skeletal, muscular.
Okay, so skeletal muscles contract and push on the lymph vessels, but what keeps the fluid going in the same direction?
Valves.
Valves, yeah. So lymphatic vessels are most like veins. Lymphatic vessels, bye sweetheart, are most like veins. Okay? Then we talked about primary and secondary organs, and we talked about the primary ones is the bone marrow. So bone marrow is one of the primary, and the second one is the thymus gland. Now, all your lymphocytes, and this would give me a good opportunity to say that not all blood cells are lymphocytes, right? What are the three kinds of cells? Red blood cells, white blood cells, or three types of formed elements. Red blood cells, white blood cells, and platelets, right? What's the job of platelets? Clot your blood. What's the job of white blood cells? To protect you. And red blood cells carry oxygen. Underneath the umbrella of white blood cells, there is a group of white blood cells that are called lymphocytes. And that is just a subcategory of white blood cells. So B cells and T cells are two types of lymphocytes. They both originate in the bone marrow, but B cells actually mature in the bone marrow, whereas T cells will migrate out of the bone marrow and to a gland. What gland is that? Thymus gland, and they will mature there. Yes?
So they also types of natural killer cells?
Natural killer cells also come from that lymphoid stem cell, but they don't end up going to the thymus gland to mature.
So are B cells they're just natural killer cells?
No, B cells are not. That's a totally different category. Yeah, I'll show you a big picture. We talked about lymph nodes and spleen. Both are a job they have to filter, but the spleen filters what? They both filter. These are both filters. What does the spleen filter? It filters your blood, whereas lymph nodes filter your what? Tissue fluid. So they're both looking at a fluid. They're both allowing that fluid to move through them, but lymph nodes are filtering your tissue fluid, whereas your spleen is filtering your blood. Okay, so these would be considered secondary organs, okay? Along with here, let me show you a quick picture first. Here's a lymph node, here's a spleen, not a human spleen, but tonsils would be a secondary organ. Take a look at this picture. So here's your blood stem cells, which all come out of your bone marrow. Okay, then lymphoid stem cells, those are going to make these three types of cells. B lymphocytes, T lymphocytes, and natural killer cells. Natural killer cells could have been T cells if they had gone to the thymus gland, but they didn't. Okay, over here, your myeloid stem cells, okay, this is, you have red blood cells whose job is to carry what? Oxygen. Platelets are for blood clotting. Then you have this whole group of cells over here, also including monocytes. They're not in this picture. And this right here, this group right here, this is part of your innate immune response that everybody is born with. And the most numerous of those, and they will neutralize the situation, and they're first on the scene. Who are those?
Neutrophils.
Neutrophils. Yeah, our neutrophils. Okay? Now, eosinophils, you don't need to memorize that. They just go for the big targets like worms. Basophils are like mast cells. What do mast cells do? Secrete histamine. Yeah. Okay, exactly. And you also have monocytes. So this is just kind of breaking down these two categories here. All right. So those are the structures we have to work with. Now let's talk about how we actually defend ourselves. The first line of defense, just keep things out of your body. So we have all these different barriers. It's like a castle, you know. We have arrows we can shoot. We have bombs we can throw. But first we build a what? Wall, right? To keep things out of our castle. So what are our walls that we have? We have things like skin and hair and mucus secretions and salivary secretions. We have oil. We have low pH in our stomach. All of these things are barriers that we can use to keep things out of our body. But if somehow they get across that barrier, they get into our body, then what are we going to do? Now, first of all, how do you know it's a thing that shouldn't be there? For instance, when I was leaving right at the end of class, actually during class, and I was running over here, I saw a girl walking by. I wasn't sure if she was a girl or a grown-up adult. Maybe she's a senior. Maybe I never had her. And she's walking, and I'm thinking, I've never seen her before. And I'm watching her, and I'm thinking, what could she have in her backpack? I couldn't tell self from what? Non-self. I need some surface marker that is an indicator to me that it's a student. So what are those markers in our body that tell our cells you belong here or you don't belong here? Those are antigens. Now, if I start attacking a student and I go, oh, this student shouldn't be here, kill him, but he really is a student here at Oak Park, what do you call that? It's called a something disease, autoimmune disease, when I get confused. Does that make sense to you? Okay? All right, so these surface markers right here, okay, these are markers. They could be a protein, they could be a carbohydrate just on the edge of the cell. And our cells can touch one another, right? And go, this is acceptable here, this isn't acceptable here. Hopefully all your cells never stimulate an immune response in your body. Hopefully all the foods you eat don't ever have an allergic reaction to your body. So who do we call if we need to take care of them? We need to bring in some forces. Now, your general police force are all of these guys. Okay, this is part of your innate immune response. Everybody's born with it. It never changes. It has the same consistency. It always, throws bombs if it needs to. It eats things that are foreign. And then you have your special forces. These have memory. They get better and better at defending your body against a singular pathogen. Okay, against a singular pathogen. You have to have specific B and T cells for every single pathogen that you come across. So let's look over these because we've talked about these guys already. So let's talk about each of them and try to remember what they do. So who's first on the scene? Neutrophils. So we know these guys. Neutrophils are most numerous. They're first on the scene. We don't need to worry about eosinophils or basophils. So don't worry about that. Here is a complement protein. What do they do? What do the complements do?
Indeed,
They drill holes. Yeah. So these guys, they drill holes. There are other complement proteins that set off alarms, and we'll talk about those in just a minute. Natural killer cells, what do? They kill. Yeah. What do macrophages do? They eat. Now, before they were a macrophage, they start out as a monocyte, and then they become these large macrophages. They're long-lasting. What do dendritic cells do? They eat, and they clean up the mess from the war, from the little disaster going on. Now, dendritic cells and macrophage cells, these are examples of antigen-presenting cells. These are cells that will eat and display the bad guy. And when they eat and display, they're going to display on MHC what? 2. I will help you. Remember? MHC1 and you're done. You display on an MHC2, that means you ate it, you destroyed it, and you're displaying it. You're saying, here, who can you try to find virgins? Okay? Now, mast cells, what do? Yeah, they secrete histamine. Okay? And histamines will make your blood vessels, dilate them, makes it easier for other cells to get there. Now you'll notice natural killer cells are kind of on either side here. Again, the idea here is that they kill. Okay, let's talk about B cells. What do B cells make? B cells are all about what? Antibodies. Do antibodies kill anything?
No.
No. What do?
They mark.
Mark them. Mark for destruction. Okay, and then our T cells, we have 2. Look right here, CD4, CD8. Remember I showed you what that meant? CD4, I am for you, not against you, that stabilizing one. These are your helpers, and they'll amplify the immune response, and CD8, these are going to kill. Okay, now, what they're not showing is these cells that you make here in your special forces, you also make some what kind of cells? Memory cells, and that's for next time. Okay, questions or concerns on this, what I've written on? All right, so when you come across a pathogen for the first time, you will have an inflammatory response. That inflammatory response is going to be due to some of these key cells right here. Granulocytes, the most numerous one there is the neutrophil. What is he going to be doing? He's going to be eating, right? He's first on the scene. Macrophage, this is an antigen-presenting cell. He's going to be doing what? Eating, okay? And when he displays, he's displaying on an MHC what? 2. Good. Okay? Dendritic cell, also an antigen-presenting cell. He's going to be eating. He's going to display on a MHC2. Okay? And these will then be able to talk to your specific or adapted, acquired immune response. But they go around eating, destroying, trying to clean everything up. So you can see an inflammatory response here. So we have a wound, so we have a cut. These things right here are bacteria. What are these blood plates? Why are they coming over here?
To clot.
Yeah, to clot. This mast cell is secreting what? Histamine. And that histamine is going to make these blood vessels leaky, so it makes it easier for cells to get out. Here's a neutrophil, most numerous on the scene. He's going to be eating. Here's a macrophage. He's eating, and he's going to be displaying what he has taken care of because he's an antigen-presenting cell. He's also releasing a cytokine. He is releasing an interleukin to amp up the whole immune response. He's saying danger, danger, danger. This is the inflammatory response. What are some consequences of an inflammatory response? I'm looking for the pin go away thing that I made. Pin go away. Pin. Let's see. Did that do it? what does histamine do? Histamine will take these spaces and make them bigger. And when they're bigger like this, then cells can get out better. And in addition, fluid gets pushed out too. That causes that area that's inflamed to what? To swell. It causes it to swell, yeah. If you take antihistamine, it won't swell as much, okay? So it causes it to swell. You get heat in that area. It's tender. It's painful because that swelling pushes on nerve endings and makes it, tender. But all of that is to allow cells to get there, and also that heat might kill off the bacteria. So that's your inflammatory response. What are some other things that can happen for your innate immune response? You have these complement proteins that drill holes, and so the water rushes in the bacteria. You have natural killer cells, and they're killing, okay? What triggers an inflammatory response? Two things. Tell me. Invaders and? Okay, invaders can cause infection. I'm looking for something else. Damaged tissues. Yeah, damaged tissues, right? Because if somebody punched you really hard, could you get swelling and hurt from that? Sure. That wasn't because an invader went in there. It's because tissues were destroyed and you have an inflammatory response to that. You have a swelling. If you turned your ankle really bad, it could swell, right? Okay. So, let's see. We can do these questions. Classlab.com, and here's your code.
Oh, same one. Are we always gonna?
Is it? I don't know. Beats the heck out of me. I'm wondering if is this the same one for your lecture today?
Yeah.
I'm wondering if it's the same one for that day or for that presentation. I don't know. I don't know. Oh, Percival Park. Yeah. We need to have theme days where you have to become something. We'll have to decide themes, like favorite movie characters. Okay, did we get 100?
Yeah, boy.
On the first one, does everybody understand that one?
Yeah.
Yeah.
You want me to go over? Okay. Oh, poo-poo. Okay, so a couple of you forgot to hit E. Mucous membranes are also a thing to keep, to keep things out of your body. Yes?
Can you go over number 1?
Yes, I can. Okay, so your protective proteins, that is part, these proteins, these hole drillers or these alarms that you have, that is part of your innate. You're born innate, you're born with it. It does inflame that system because part of those protective proteins, when they're released, it sends off signals to that area that there's there's an injury or an invader. It is a series of proteins. They're made out of proteins that are cruising around in your plasma, and they can drill little holes and destroy bacteria. Okay. All right, and then are you good on 2?
Yeah.
Okay. All right, and then you remember your monster quiz from earlier, so we don't need to do it now unless you think it's somehow going to be helpful. Ah! Do you want to do it again, or are you good? What? Oh, do you want to do it? Okay. Do you want to do it individually?
No.
Okay, I'll divide you into 2 teams.
The barrel. Well, I'm on your team.
Do you know what team you're on? Where are the barrel busters? Raise your hand, barrel busters. I've got one barrel buster. Who else is a barrel buster?
Who's Dark Star?
Okay, I got 3.
Can
Okay.
you change our names? You should change it to nice ringtone.
Oh. Then you're probably updated. If it doesn't have it on there as an update for you, then you don't need to do it. Yeah, it was like if you didn't have the OS one, then it came up as an update. As far as I read from what I read in the email. So you should just probably go and do that one. Sweet, then you're set. Thank you. It looks like barrel busters. Let's go barrel. I mean heat scorchers. I'm trying to be encouraging. Oh, barrel busters. Nice ponytail.
Oh my, it's a man.
Is it a man tail? I don't like, we discovered in 4th period, maybe 2nd period discovered it too. It didn't matter if you got it right or wrong, it was first to finish.
Yeah.
That's not a good thing.
I know, no, but you have to redo the question if you get it wrong.
Oh, so that slows you down.
It's kind of incorporated.
Okay, okay. All right, so almost all of us got this. Really, I could have said all 3 of the above, right?
Yeah.
Okay, and number 2, oh, we all got that. Good. Anybody need more on that?
No.
Okay. 3, the spleen, oh, we all got that. Okay, we missed 4. B cells and T cells mature in the bone marrow? No. B cells and T cells originate in the bone marrow, but how do we fix that? T cells mature in the thymus. Perfect. Okay, 5, the inflammatory reaction is, oh, we got that one, on D. Anybody need me to go over 5 and 6? Were you lucky, not good? All right, 5, 6, we got 100. 7, we missed. Macrophages are the biggest eaters, and they do set off cellular alarms. Neutrophils are first, but macrophages are bigger, and they last longer. Okay? And dead white blood cells who have fought the good fight, what do we call them? Pus. That's pus. And a sign of infection. 8, some of you missed this. Dendritic cells do not release histamine. Who releases histamine? Mast cells and basophils in the blood. 9, they do that. So they up the response. That's one role of complement proteins, and they are hole drillers. Part of your innate response. And then everybody got 10. Okay, so now we just need to differentiate between B cells and T cells. Okay, and this was part of today's lecture, so you should probably be pretty good on this. B cells targets are the real viruses, and not only are they the real viruses, but what they release, their antibodies, target the real viruses, right? And bacteria. They're all about the real deal. However, as much as they're about the real deal, they don't do any killing themselves, right? They abdicate that to other cells. But they do come into contact with them directly, and they make antibodies which tag them. T cells, though, they go after only our own cells, or foreign eukaryotic cells. They're all about the eukaryotic cell that has been taken over by a Canadian terrorist and is displaying the antigen on its surface right here, and then they will do cell-to-cell combat against it. We talked about the whole virgin thing, that B and T cells you have, if right now I had a shot of some pathogen, since I heard him earlier, I might as well only get it. And if I give him a shot of a virus right there, and I just jammed it in his arm, okay? He has maybe one virgin B cell and one virgin T cell that can recognize that virus. And if I gave him a shot of this other one, and I've given him 2 viruses, he has a different virgin B cell and a different virgin T cell. Who would recognize those? Where should those virgins hang out in order to try to ensure that they come in contact with that particular pathogen?
Lymph nodes.
Yeah, in the lymph nodes, because the tissue fluid will pass through those lymph nodes and can check for it. Looking at the beads. Okay, so here's an antigen presenting cell. Let's say he is a dendritic cell, and
He is one.
is he
It
labeled?
says right there.
Oh, okay. So he engulfs it, and he's going to display it, and he's going to display it around until he can find that virgin that recognizes it. Now this helper T cell, he will actually become, you'll get 2 other cells besides helper T cells from him if we looked at the cell-mediated response. What else would you get? What are the other kinds of T cells we could get besides helper T cells?
4 and 8.
The what?
The 4 one and the 8 one.
Okay, well this one right here would be a 4 one, so that would be a CD4 stabilized. Helper cells, you could get a cytotoxic T cell and a memory cell for next time. Okay, so those are the 3 cells you get once that virgin T cell is stimulated. Okay, here is a B cell. He comes in direct contact with the pathogen. He will, if a T cell agrees with him, he will then stimulate that B cell to make 2 kinds of cells. Plasma cells, which secrete all the antibodies, and this is clonal selection, where you make millions of them. They'll all release antibodies and they'll make memory cells. Okay? And antibodies mark that bacterium for destruction, like a macrophage is going to eat it, and the memory cells are for next time. T cells, if you remember, we already went over this just a moment ago. So here we have a macrophage eating. He's breaking it up, displaying it. He will stimulate that virgin T cell to make a cytotoxic T cell, or later a memory cell, which is not in this picture, a memory cell, right? And then you have helper T cells. The thing to remember is the difference between MHC1s and MHC2s. Who has MHC1s? Pretty much all cells, right? The only ones that don't have MHC1s are your antigen presenting cells, which are your macrophages, your dendritic cells, and your B cells. These all have MHC2s. So just a few types of cells in your body have MHC2s. Most have MHC1s. Which means if you are displaying that pathogen, we're going to have to kill you.
Excellent.
Yes,
Can
baby.
you go over again the difference between MHC1 and 2?
Yes, I can. MHC1s display the antigen. That's just the structure of how they display it. They display it with just literally one arm, in a sense. And if you display a pathogen like that, that means that tells what kind of cell you are. It's kind of like name tags. I could have a teacher name tag. There could be student name tags. It's just a way to tag you. What do we have more of on this campus, students or teachers?
Students.
So students are like MHC1s. So if you get at the photocopy machine and you're copying a test, you're fine. If you're a teacher copying on the photocopy machine, you're fine at an exam. But if you're a student at a photocopy machine, right, you're in trouble. Why? I can see you have a label that says student. But if there was a teacher doing it, it would be okay, right? So same thing here. If you're an MHC1 and you're displaying a pathogen, you're infected. So I'm going to have to kill you.
And who will kill them?
A cytotoxic T cell might come and kill them. A natural killer cell might come and kill them. Yeah. If you are an antigen presenting cell, I'm a teacher. It's okay for me to have a test on campus and photocopy it. And so when I display it, I'm in charge of it. I own it. It belongs to me. So it's okay. And if you display on an MHC2, it means you ate that thing and you're displaying that thing and you're looking for somebody who can help you kill that thing.
Okay.
All right, and so all of this, when we look here, at T cells, you have these stem cells in your bone marrow, and if you don't go to the thymus gland, you'll just be a natural killer cell, and you'll kill things. But if you do go to the thymus gland, you can be a cytotoxic, who's all about killing, a helper, who's all about helping, and a memory cell for next time. And again, hopefully this graphic will, if you review this graphic, that kind of sorts things out. Also, you have pictures in your book that explain both types of immunity. Then here at the end, we have innate, which you're born with. We already talked about this. Inflammatory response, you've got that. Acquired means I got it after I was born. Whatever I got after I was born, did I get it because I own it? It's active immunity. Either I got sick with it, and that's why I have memory cells, or somebody gave me a shot of a weakened version of it, and that's why I have memory cells. This is, I own it, it's active, I acquired it in my lifetime, but it's active, it's my stuff, okay? If it's passive, I'm borrowing it. It's short-term immunity. I have no memory if it's passive. Am I protected? Yes. Am I protected for the future? No. If it's active, I'm always protected. This is a crisis situation. Or breastfeeding. You know, you're helping your baby while you're breastfeeding. You're lending it some antibodies during that time. Okay, we talked about the two kinds of chemicals. Interferon. Think I'm trying to interfere with that virus infecting others. I gave you the example, what if a pedophile moved into your neighborhood and you know that that pedophile's in the neighborhood? You're going to lock your doors and windows and keep a careful watch on your children. That's like interferon. When a virus-infected cell says danger, danger, and it warns the other cells. Interleukin, when that is secreted, that one is saying, hey, let's fight harder. This is the Red Bull that you feed them. This is the sugar that you feed them and amps them up. This is the coffee that you give your immune system. B cells make more antibodies. Cytotoxic T cells and natural killer cells kill more. And then what happens when things go wrong? Allergies, you're responding with immunological response to something that you shouldn't worry about. It could be just as bad as sniffly nose, or it could be as bad as an anaphylactic, going into anaphylactic shock. And then long, slower response, these would be immediate responses. Slower response would be poison oak, poison ivy, cheap jewelry, and you slowly respond to it. We talked about blood typing, okay? This type of blood, an anti-A antibody would attach here, an anti-B antibody would attach here, an anti-RH antibody could attach here. So you can give your blood to anyone who won't develop an immune response against it. And you have to watch out for tissue rejection because you will attack any tissue that's foreign that was given to you. So you have to take immunosuppressant drugs. Diseases like lupus and multiple sclerosis, these are diseases where you do attack your own tissues. And that is it. Okay, questions or concerns? All right, good job. Have some toast. Don't stay up too late. Remember, I'm not at school tomorrow. I'm at a conference. I'll be here Friday. So review tomorrow, tonight,
Do we
something.
have